Welcome to the ITFreeTraining video on transitioning to IP6. Currently, it is estimated that just under 20% of the Internet is IP6 ready, meaning the end user has little option but to use IP4. When there is no IP6 native protocol between you and your destination, there are some transition technologies available that may be able to bridge the gap. In future videos, I will look at some of the many transition technologies available. This video will give you a basic understanding of how these transition technologies work. Consider the following. You have a desktop computer that is connected to an IP4 network. This computer wants to communicate with a computer that is located on an IP6 only network. Once the computer works out what data it wants to send, the next step is to work out how to send it. Since the destination network is IP6, the data will be placed in an IP6 packet. The next problem is the computer will not be able to send the packet because it is on an IP4 only network. To get around this problem, the next step is to place the IP6 packet into an IP4 packet. This will allow the IP6 packet to travel over the IP4 network. However, the next problem is the IP4 network will not know how to route the packet to the IP6 network. To get around this, many of the transition technologies will create a tunnel over the IP4 network. This will allow the IP4 packet to be routed to the IP6 network. When the IP4 packet reaches the IP6 network, it cannot be routed on the IP6 network. So the IP4 packet is removed to leave the IP6 packet. The IP6 packet will be routed like any other IP6 packet to its destination. Once it arrives at the destination, the data packet can be used by the destination computer. This is a common way transition technology works. However, different transition technologies can be used depending on what network infrastructure you have. Let's consider a different example. Consider that your company has two networks that are using IP6 at different geographical sites. If a computer on each network wants to communicate with each other, the problem is that the Internet between the two computers is still mostly IP4. Thus, there is no common protocol between the two networks. In order for the two computers to communicate, a tunnel is established between the two sites. Now, for the two computers to communicate, the computer sends an IP6 packet over the network. When it reaches a router connected to both the IP6 and IP4 network, the packet is placed in an IP4 packet and sent over a tunnel. Once the IP4 packet gets to the end of the tunnel, the IP4 packet is removed and the IP6 packet is sent to the destination. Not all IP6 transition technologies require a tunnel, however. In later videos, we will see that some transition technologies use servers to bridge the traffic between different networks. The good news is that on newer operating systems, you can configure IP4 or IP6 or both. Configuring both is referred to as a dual stack. This includes Windows, Linux, and mobile devices. Newer operating systems will attempt to use IP6 first, and then, if this is not available, use IP4. Routers can be configured to use both. IP6 packets are different from IP4 packets, so configuring both will not affect your existing network or devices on those networks. This allows the administrator to deploy IP6 as quickly or slowly as they wish, without affecting existing services. I hope you found this video from ITFreeTraining helpful. In the next video, I will take a closer look at what IP6 transition technologies are available and how to configure these transition technologies. Until then, thanks for watching.